Okay guys, we're going to go ahead and learn how to find the solution of 2 points based on graphing. So what we're going to do first is we are going to remember that to graph a point or to graph a line, I use the form y is equal to mx plus b, where m is the slope and b is the y-intercept, or where it hits the y-axis. So our first line we're going to go ahead and do in red. I'm going to start with my intercept. So I see plus 3, so I start up 3. And then I see my slope is a -1, so that means I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. If I wanted to go backwards to do the left side of my graph, I go back to my original starting point here, and I go oppositely. So last time I went down to the right, so now I'm going to go up to the left. And this works with every single line that you choose to draw, or you're asked to draw. You can always go backwards as long as you do the opposite. So I went down and right, so now I have to go up and left. And then you simply connect your dots together. I'm going to pick purple to do the second line. And again, I'm going to start with the y-intercept. So I'm going to start down 6. 6. Then I'm going to go with the slope of 2. Remember, slopes are fractions, so 2 over 1. So I start going up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And I typically continue doing my dots until I hit either another line or I go back to my first line and try and hit it again. I want to be as accurate as I can, so I like to go off of more dots versus less dots, especially when we don't always have a ruler provided for us. That way we can be the most accurate as possible. And then it asks for the solution point. The solution point is the point at which the 2 lines meet, which in this case is right here. So that's the point 1, 2, 3, 0. Okay, same idea. Y equals mx plus b. Slope and my y-intercept. So I'm going to use red again. So this first guy is going to start down at -3. And then we're going to go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And then to be safe side, just in case we might meet backwards, I go down 2 to the left 1, down 2 to the left 1. And connect my dots. The second line says I start down 1. And then I have a slope that goes up 1 over 1. And then again, typically if I hit another dot or I hit that line, I'm probably just going to stop because I've already found my solution. And this time they meet at 2, 1. Third problem, oops, I need to move up my solution point since my face is in the way. I'm going to go ahead and start up 5. My slope is an invisible 1, so I go up 1 over 1, up 1 over 1, up 1 over 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Connect your dots. If you notice in my second equation, there's no b value. That b value is like saying +0. And we know if I see that, it's the same thing as not needing to write it, which is why they don't write it, because your starting point is just going to be the non-existent number 0. Now I'm going to do my slope of down 4 to the right 1. Down 4 to the right 1. Go backwards, go up 4 to the left 1. Boom, I've hit my spot. It's right here. So -1, 2, 3, 4. Now, when I have a y equals, that is going to be where my y value is always 2. And typically people say, where's my mouse? Typically people say that because the y-axis, I'm going to highlight that so you can see what I'm talking about. Because the y-axis goes up and down, therefore any lines that say y equal go up and down. Well, let's have a discussion about that. Say I'm going to talk about this line over here. That is the 1, 2, 3, 4. That is -4. Now, if I'm discussing this dot right there, can't really see that. That was a bad color choice. Say I'm discussing this dot, still bad choice. Say I'm talking about right there. Right there, my y value is 1. If I go up here, my y value is now 4. I want my y to be consistently 2. So if I continue just putting dots, I notice my y value is not changing. However, that contradicts the equation where y is always 2. So unfortunately, when I have y equals, my line is horizontal. And it's horizontal where the y value is 2. People think, well, but my axis goes up and down. You're correct. Every time I keep going up, my y values do increase. But I don't want my y values to be increasing. This time I want them to stay that constant 2 value. Constant 2 is walking across the floor. Think about you're trying to go, whether or not you're going to go up a hill or if you're going to go, upstairs or if you're staying on one level. If you want to be constantly on the second floor, you don't want to have to go up and down. That causes this to go horizontal, which is why we go vertical. All right, let's go ahead and plot our second one. So down 4. We're going to go down 3, 1, 2, 3 to the right one, and I see I can't go anymore, so I have to go backwards. So up 3, 1, 2, 3 to the left one, 1, 2, 3 to the left one. And my solution point is at -2, 2. There for now. Number 5. The system below models the height of tomato plants in centimeters over time, measured in days. What does the solution mean in terms of the original situation? Well, I see instead of x and y, I have h and d. And I'm just going to write, something off to the side so I don't forget. Y equals mx plus b. So we're going to compare which of these letters is going to be similar to the other, what I'm going to pretend I see. Since my x is typically what I refer to, and that's my horizontal, I see that my d is going to replace the x because he's got the slope right next to it, and it looks like the intercept. So down below, I'm going to say that this is my d. And let's be strategic. Let's go back and read it. What do we think d means? The system below models the heights of tomato plants. Okay, there's the word heights. In centimeters over time measured in days. Sorry, I hit the side of my computer. It causes everything to zoom out. What does the solution mean in terms of situation? So I have two things it could be. It could be height, or it could be days. Well, does it make sense to use the letter D for height? No, it makes sense for days. So down below, our x, instead of our x, we're going to have the amount of days. conversely, when we go up and down then, we're going to call this my height. For a second, I thought I was going to be too close and I wouldn't be able to write some numbers. And we see we don't have any given numbers associated. We don't know if we're going up by 1s, by 2s, by 10s, by 20s. So we're going to have to kind of guesstimate. Well, if I take a peek over here, I see that my intercepts are under 10. So it doesn't make sense to go under 10. And I see that the highest roughly I might get is 5. And I see 5 is a little over halfway, so I should be able to go ahead and just do this by 1s. So 0 centimeters, because we're in terms of centimeters, 1 centimeter, 2 centimeters, 3 centimeters, 4 centimeters, 6, 7, 8. So we go up to 8 centimeters. And then because we have to be realistic, it talks about a full day. So again, this is 0 days, 1 day, 2 day, 3 day, 4 day, 5 days, 6 day. Now let's go back and start like we normally do. We're going to go ahead and plot this first one in red. So I start up at 1. And even though I'm only given the first quadrant, we should recognize that if I haven't gone any days, if I plugged in 0, I should just get 1. So x is 0 or day is 0. I have 1 centimeter as the height of this first tomato plant. From there, I'm going to go up 3 to the right 1. Up 3 more to the right 1 more. And then I see after that, I'll be off the graph. Now, there's no reason of drawing the left-hand arrow because it's implying that I would continue going negative. But can I go negative days? Can I go negative time? Is time travel real yet? No, it's not. So because it's not, I end up just leaving this as a ray instead of a line. Let's go ahead and graph the second one now. So we start up at 5. Wow, this is a really tall plant. And then I go up 1 over 1, up 1 over 1, up 1 over 1. Again, he's only a ray as well. And I see my solution point pop out. So I see 2, 7. Great, but what does that mean? It asks me right here, what does the solution mean in terms of the original situation? So we saw we were dealing with tomato plants. So I should be able to infer that my tomato plants what do? Well, we were trying to have a solution point where the lines would meet, which means that they would be an equal height. So how many days will it take for them to be the same height, essentially is what this question is asking. So the tomato plants will be the same height, which in this case, they end up being 7 centimeters. After only 2 days. Only the reason I say 2 days is if you notice, my x is 2 in terms of days, y is 7 in terms of height. So after 2 days, they'll be the same height of 7 centimeters. All right, number 6. Now we should be able to start puzzling out the solution for this problem pretty quickly. We should say, hey, last time my y equals, I was left and right. Now I have x equals, so he's going to go up and down. And again, we could logic it out and reason it out for why it's up and down. I want every x value on this line that I just drew to always be 5. That's what that equation is meaning where it says x is 5. So if I pick some random points, say here, what is my x value? Well, he's 5. What is my x value down here? Still 5. And here? Again, still 5. So because every time I pick a point on that line and he happens to be 5, that's causing that equation to stay true. And we want things to be true in math class. We want them to make sense. So again, if I see x equals, we go up and down. If I see y equals, we go left and right. Again, we're going to go ahead and plot our second one. Start down at -2. And a slope of 1, so up 1 over 1. Keep going till you hit. Not the best at drawing the shortest of lines on my computer, sorry. So his solution point exists there. So that looks like 5, 3. Oops. All right, number 7. We already can see in the directions that we're going to have to rearrange the equations in order to solve. That means that we need to try and turn it into our y equals mx plus b. So that y is on one side, all the other stuff's on the other. Or y is on one side, all the other stuff's on the other. I hear sirens. Ooh, someone's in trouble. So in the first equation, I have 2x being added to my y. So I'm going to undo that addition with subtraction. 2 x's are canceled now. So I have y is equal to -2x plus 5. And you're probably saying, whoa, 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 whoa. But 5 was there first, so I should say 5 minus 2x. Well, you're correct. The 5 was there first. But I want to keep it going y equals x number. It could be an addition or a subtraction. It doesn't matter. Y, x number. Even if my x has a term, I still want him to come next. So I'm going to go ahead and start by plotting him up 5. Then we're going to go down 2 to the right 1. And backwards. Because you never know exactly where you're going to meet, if you're going to meet. And I got off a little bit towards the bottom, so I'm going to try and fix that. It's hard to do this because I can't exactly see where my finger is going to line next. Second one, again, I need to get y by itself, so I'm going to undo that subtraction of x by adding it. Now he's gone. And my 2 is already positive, so it's plus 2. So I start up at 2. I go up 1 over 1. Boom, that was the easiest line I've ever drawn. My solution point exists there, so 1, 2, 3. I liked having it over there. And then I need to move him over. Do I need to rewrite him? Nope. So start up at 3. Up 2 to the right 1. Up 2 to the right 1. Go back, start down 2 to the left 1. Down 2 to the left 1. And then connect your dots. Second one, though, is not ready to go ahead and start graphing. I need to do that. So I'm going to add over my 2x. So they're gone. Y is equal to 2x minus 6. So start down at 6. Go up 2 to the right 1. 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 Up 2 to the right. What the heck? They're not meeting. They don't meet. Just like with all things in life, there comes a time where you just might not ever cross paths with someone. I might never cross paths with insert famous person's name. So this is called a no solution. My two lines do not meet at any point, and they don't meet because they're parallel. And I could have looked at it right away and say, I already know they're not going to meet, and here's why I meet. No, they're not going to meet. When you have the same slope, they turn out to be parallel lines. So if I see parallel, I should say, hey, the same slope. My 2x here is the same as my 2x there. So it means they will never meet. Oh, those are attached. All right, first one I can go ahead and graph. No need to rewrite. So up 2 to the right 3. Go back to the start, down 2 to the left 3. Connect your dots. See the second one, I see that it's not ready to go, so I have to add over my 2/3 x. Those guys are gone, so I have y is equal to 2/3 x plus 2. Wait a minute, that's there, and then that should be there, and then that should be there, and then that should be there, and that should be there, and then it sits, if I could draw straight, exactly on top of each other. So this is another crazy example where sometimes you just try as hard as you can never get away from someone. So this solution is called infinitely many. I'm missing an A in the strategic spot. There you go. Infinitely many solutions happen when you have the same line. Or you have some kind of variation of the same line, so it ends up reducing down. That means that no matter what you pick, it's always going to be a solution. It'll always work. You can plug in 5 and you can plug in 5 and they'd still meet. You can plug in 10 and they'd still work. You could plug in negative 0.2375 into both and they would still meet at the same spot, the entire line. All right, that's all I have for you. Enjoy your homework.